So in this video we will be discussing the concept related to the minimum distance problems. Okay, so our video is based on the concept of the problems related to the minimum distance, that is minimum distance. So there are the two cases for this concept. So first I will discuss the first case. So let us assume the first case is like the data given in such a way that our velocity of boat with respect to river, it is greater than the velocity of river. Okay, so in this case let me draw, this is our river. Okay, and this d is the width of the river. It is flowing in the direction like this with the speed vr. Okay, and let us assume this is the direction of VBR and this angle is the theta. So for the minimum distance, let us assume that what is the minimum distance in which this boatman can row his boat to the other bank of this river. So the minimum distance will always be greater than or equal to d, because this much distance he will always have to travel, no? So its minimum distance will always be equal or greater than this d. Here d is the width of the river. Okay, so in this case where velocity of boat with respect to river is greater than the velocity of river, let us assume in this case our drift is 0, that is our x. The formula for x was like the component of velocity which is responsible for the drift, that is vr minus vbr sine theta into the time taken to cross the river, that is d divided by vbr cos theta. Okay, so for the minimum distance, let us suppose it is equal to, like let us imaginary we are assuming that this boatman is going in this direction and this is the x. We are just imagining this condition. So this d distance he has traveled. So in this equation, in this triangle, right angle triangle, we can write d square is equal to x square plus this d square. So for this d to be minimum, what we can minimize is only this x. Okay, so in this case let us assume our x is equal to 0. Okay, so our x is equal to 0, that means vr minus vbr sine theta, this quantity is equal to 0. Okay, so here on solving we will be getting sine theta is equal to vr divided by vbr. Okay, so this is the value of theta in which direction the boatman should row his boat so that he will cover the minimum distance to cross this river. Okay, so here theta we can write, theta will be equal to sine inverse vr divided by vbr. Okay, so this is our first case. This is an important formula. In second case, let us assume that in second case the numerical data is given in such a way that our velocity of boat with respect to river is less than the velocity of river. So here velocity of river is greater than velocity of boat with respect to river. Okay, So as we know that this is our river, it is flowing, and this is the D width, and let us assume this is the VR, this is VBR. Okay, and our boatman is going in this direction. This is our X. X is what? Drift. Okay, and this is the D, and let us assume D, capital D, is the distance traveled by the boatman to cross the river. So in this right angle triangle, again I can write as d square is equal to small d square plus x square. Here again we have to minimize this d, then this d is constant, actually we cannot minimize it. Whatever we can do is with this x only. Okay, so again if this x is minimum, then our d will also be minimum. D will also be minimum. Okay, as we know that the formula of this drift x is equal to, that is what, time taken to cross the river, d divided by VBR cos theta into the component of velocity which is responsible for the drift, that is VR minus VBR sin theta. Okay, so we can write it like d divided by VBR secant theta into VR minus VBR sin theta. Okay, so like this is our equation number, let us assume. So to minimize this term, we will be differentiating this equation with respect to theta. So our differentiation with respect to theta will be differentiating this term, we are applying the multiplication rule. So d by VBR is constant. Okay, so the differentiation for that secant theta is secant theta dot tan theta into this second term is at constant VR minus VBR sin theta. Okay, so d divided by VBR we are taking as common term here, plus now secant theta is constant. Okay, into differentiation of this term is negative of VBR cos theta. Okay, so this is our differentiation for this equation with respect to theta. Now to minimize it, we will be using dx by d theta will be equal to 0. So here we will be getting some value of theta at which our x will be minimum, so that our distance traveled by the boatman will also be minimum. So let us proceed it. Here by putting this value, this equation equal to 0, our d divided by VBR will be cancelled out. So here we can directly write secant theta into tan theta into VR minus VBR sin theta, that will be equal to secant theta into VBR cos theta. Okay, so our secant theta will be cancelled out again. So here we can write tangent theta as the sin theta divided by cos theta. Okay, into VR minus VBR sin theta, that will be equal to VBR cos theta. Taking this cos theta in the right hand side, we will be getting and multiplying this sin theta into inside, that is VR sin theta minus VBR sin square theta, that will be equal to VBR cos square theta. Okay, so here again solving VR sin theta is equal to VBR into sine square theta plus cos square theta. Okay. So this term, as we know that this is equal to 1 only. So here sine theta we will be getting is VBR divided by VR. Okay. So this is the value of sine theta. That means our theta will be equal to sine inverse VBR divided by VR. So in this direction, at this angle theta, a boatman should row his boat so that he will be covering the minimum distance in crossing the river.